Hi, you guys. We are moving on to Unit 9. You are so close. We're doing Units 9, 10, and 11, and then we're done. So look how far you've come. So this is a different kind of topic, and you might have heard the term quadratic before. They are very common type of equations in algebra, and we're going to start our study of quadratics. So let me move on to the first page here in 9.a. There's some vocab in here. A quadratic equation has a squared term. This guy right here is very important. He has got an exponent of 2, and generally it's an x squared, although it doesn't have to be an x. And that's not only do you have a squared term, but it's the highest exponent that there is. So a quadratic equation, notice number one, we're solving, which means we have equations. In Unit 8, we had all expressions. We factored expressions, but we did no solving. We haven't solved equations for a while. So equations have an equal sign. Solving means we find solutions. Find solution. And maybe there's more than one. Find solutions, which means when you plug in, your solution doesn't make a true statement. So, quadratic equations, we're going to solve them, but we're going to have a procedure. We've got a step-by-step process just like we do on most other units. First of all, we want it in standard form, and we want it set equal to 0. So if you have to move some stuff around to get one of your sides of your equal sign set equal to 0, then that's going to be one of your first steps. Then you're going to factor it. We go back to Unit 8. This is in standard form. It's got 3 terms. It's a trinomial, so we're going to use the AC method. And ultimately, we're going to end up with the 2 factors, x minus 1 times x plus 6. Remember, when it's in factored form, all of the numbers are factors. So there are no addition or subtraction between these parentheses. You have one factor times another. That's considered factor form. So we're going to use a new rule that you haven't heard of before, but it's going to make sense to you when I talk a little bit about it, and it's called the zero factor property. And essentially it says if you've got 2 numbers whose product is 0, then it stands to reason that one or both of these factors have to be 0, because we know 0 times anything is 0. So if we have 2 factors, in this example right here, and we know that when we multiply them together, whatever we plug in for x, when we multiply them together, we have to get 0, then that tells us, okay, this guy has got to end up being 0 when we plug in for x, and or this guy has got to end up being 0. So we're going to take these 2 factors and we're going to look at them independently. And we're going to say, okay, well, if x minus 1 is 0, what would x have to be to make that true? And of course, we add 1 to both sides and you get x is equal to 1. And when you plug that in up here, you go 1 minus 1. Yep, that's 0. That's one of our possible solutions that will make this entire quadratic equation 0 on the right-hand side. And the second one would be to subtract 6 from both sides, and you get x is equal to minus 6. So either x is equal to 1, or x can be equal to negative 6, and those are solutions for this equation, meaning that when you plug either one of these numbers in up here for x, you will in fact get 0 on the left-hand side of the equation. So that's what we're doing. Let's do a couple. Okay, so notice these are kind of easy because these guys are already factored. They are already set equal to 0. So basically somebody's done the factoring for you. Here is your factored form, and you are going to take each factor, and we don't really need those parentheses. Don't need it. We're going to take each factor and set it equal to 0 individually and solve it. Now this is pretty straightforward. You're going to add 3 to both sides and you get x equals 3. Over here, you're subtracting 1 to get the x alone, and you get x equals minus 1. These are your two solutions. Now, I want you to notice something, and we're going to expand on this, but when you start out with an equation, look at the highest exponent you see, and that's how many solutions you are going to have to your equation. The equations that we've been dealing with to date, x plus 3 equals 10. So 10. This is x to the first power. There's one solution. And of course, we know it's 7. 7 is the only number that you can plug into this equation and make it true. When we get to quadratics, we are dealing with an exponent of 2, which means we are looking for two solutions. Well, I just lost that. I'm going to keep going here, though, if I can. So we ended up with x minus 3 equals 0, x plus 1. We ended up with x equaling 3 and x equaling minus 1. And, of course, you can go back up and plug them in and check. So let's do this one on this page. This is already factored, so we're going to set both factors. This is a factor, and this is a factor. We're going to set them equal to 0. X equals 0. And 5x minus 2 equals 0. Well, there's our answer for that one. This one, we got to clean it up. We've got to get the x alone. We're going to add before we divide. So we end up with 5x equaling 2. Divide both sides by 5. And we get x is equal to 2/5. So our two solutions for this example 1b are 0 and the fraction 2/5. I'm going to do one more on the top of the next page. Let me scooch up a little bit. This is not factored. Now we're getting real. This is not factored. So it is set equal to 0, so that's nice. Unlike this guy over here, who you can see is not set equal to 0 yet. We have to factor him. He's a trinomial. We're going to use the AC method. We know that A is 1, B is -9, and C is -22. I've got to find factors that multiply to 22 and add to -9. So I'm thinking -11 and +2. So when I go to split up this middle term, I have x squared, and I'm going to say plus 2x minus 11x. Remember, it doesn't matter what order you put these two terms in. Minus 22 equals 0. And now we've got 4 terms, and we'll do our factor by grouping. Factoring by grouping, x plus 2, and then the other one is a minus 11. I can factor him out, and that becomes x plus 2, still equaling 0. So our last step for factoring this is x minus 11 times x plus 2 equals 0. And now this actually looks like example A on the previous page. So we've now got a factored form. We're going to take each factor individually, set it equal to 0, add 11, and I get x equal to 11, subtract 2, and I get x equals minus 2. So these are the two answers that will make our quadratic equation true if you plug in either one of those for x. It's quadratic because it's got an exponent of 2 as our highest exponent, and we have successfully solved this quadratic equation. So we'll stop this video here and continue on in the next one. Thanks for listening.